Welcome back to Sleepy Science, where we explore the cosmos, one peaceful thought at a time. Tonight, we are going to drift through the outer reaches of our solar system, far beyond Earth, far beyond the familiar glow of our own moon. Out there, orbiting the giant planets, spinning through the darkness, are worlds unlike anything you have ever imagined. Moons, covered in ice, so smooth, they shine like mirrors. Moons that spew geysers hundreds of miles into space. Moons with atmospheres thicker than Earth's, with lakes of liquid methane and rivers carving through frozen landscapes. Some are tiny and misshapen, captured asteroids tumbling through the void. Others are larger than planets, hiding vast oceans beneath their frozen shells. These are not the serene, cratered surfaces we see when we look up at night. These are strange, alien places, active and dynamic, quiet yet filled with mystery. Each one tells a story about the forces that shape worlds, about gravity and heat, about time and transformation. And tonight, as you settle in, as your breathing slows and your thoughts begin to wander, we are going to visit them, one by one, slowly, gently. We will travel to Europa's cracked ice fields, to Io's sulfurous volcanoes, to Titan's hazy orange skies. We will explore the rings of debris left behind by shattered moons and the tiny worlds that shepherd Saturn's rings into order. If you find comfort in these quiet explorations, feel free to like or subscribe, or simply leave a thought in the comments below. It helps others discover this space, this gentle corner of the internet where curiosity and calm come together. But for now, there is nothing you need to do except rest. Close your eyes if they feel heavy. Let your body sink deeper into comfort. And allow the strange beauty of these distant moons to carry you softly into sleep. Let us begin our journey. Io is the most volcanically active body in the entire solar system. Orbiting Jupiter, closer than any of the giant planet's other large moons, Io is a world on fire. Its surface is painted in shades of yellow, orange, red, and white, colors that come from sulfur and sulfur dioxide spewed endlessly from hundreds of active volcanoes. Some of these eruptions are so powerful that plumes of gas and dust rise 300 kilometers above the surface, visible even from space. If you could stand on Io, you would see geysers of molten rock fountaining into the sky, lava lakes glowing red in the darkness, and a landscape constantly reshaping itself. Mountains taller than Everest rise and collapse. New flows cover old ones. Nothing stays still. The reason for this violence is gravity. Io is caught in a gravitational tug-of-war between Jupiter and the other Galilean moons, Europa and Ganymede. As Io orbits, these forces stretch and squeeze the moon, kneading its interior like dough. This constant flexing generates immense heat, enough to keep Io's insides molten and drive the relentless volcanism. The heat escapes through the surface, creating a world that never cools, never rests. Despite being a moon, Io has more volcanic activity than Earth. It is a furnace in space, a body perpetually reshaped by the forces pulling at it. The surface of Io is so young that craters are rare, unlike most moons, which are heavily cratered from billions of years of impacts. Io's surface is constantly renewed. Lava flows and volcanic deposits bury old craters almost as quickly as they form. Some areas are covered with fresh sulfur frost, smooth and bright. Others are dark plains of solidified lava. The volcanic activity is so intense that the moon's appearance changes noticeably over just a few years. Spacecraft visiting decades apart have seen new volcanic features, new calderas, new flows. It is a world in constant motion, a living geological laboratory. Io has no water. Its proximity to Jupiter and the intense heat from tidal forces have driven away any water ice it might once have had. What remains is a world of rock and sulfur, dry and harsh. The atmosphere is thin, mostly sulfur dioxide, and it freezes out onto the surface when Io passes into Jupiter's shadow. When sunlight returns, the frozen gases sublimate back into the atmosphere, creating a cycle as regular as breathing. This thin veil of gas is not enough to shield the surface from radiation. Jupiter's powerful magnetic field sweeps past Io, stripping away particles and feeding a glowing plasma torus that encircles the planet. Io is embedded in one of the most hostile radiation environments in the solar system. If a human could somehow survive on Io, they would witness landscapes unlike anything on Earth. Towering mountains with sheer cliffs, vast plains of solidified lava stretching to the horizon. Volcanic calderas the size of cities, their floors glowing faintly with heat. The sky would be dominated by Jupiter, a massive sphere filling half the heavens, its bands and storms visible in stunning detail. At night, the glow of distant eruptions would light the landscape, casting long shadows across the alien terrain. It would be beautiful in a terrible way, a place of extremes, of fire and stone, of endless transformation. Europa is one of the smoothest objects in the solar system. While Io burns, Europa freezes. Its surface is covered in water ice so smooth and reflective that it shines like polished glass. There are few craters, and those that do exist are shallow, softened by the slow movement of the ice. Instead, the surface is crisscrossed by a network of dark lines, cracks, and ridges that stretch for hundreds of kilometers. These features are called lineae, and they tell the story of a surface that breaks and refreezes over and over again. From a distance, Europa looks like a pale, cream-colored orb, veined with reddish-brown streaks. Up close, it resembles a cracked eggshell, fragile and ancient, yet constantly renewing itself. Beneath Europa's frozen shell lies a global ocean. This is not speculation. The evidence is compelling. The way Europa's magnetic field behaves, the patterns of its surface cracks, the slight wobble in its rotation, all point to a layer of liquid water beneath the ice. Scientists estimate this ocean could be 60 to 150 kilometers deep, more than twice the volume of all Earth's oceans combined. The ice shell above it is thought to be 15 to 25 kilometers thick, a frozen crust floating on a dark, hidden sea. The ocean is kept liquid by the same tidal heating that powers Io's volcanoes, though in Europa's case, the energy is less intense, just enough to maintain warmth without tearing the moon apart. The cracks and ridges on Europa's surface are evidence of this hidden ocean. When the ice shell flexes and shifts, it fractures, creating the lineae we see. Some of these cracks are symmetrical, suggesting that sections of ice have pulled apart and then refrozen. Others are chaotic terrain, jumbled blocks of ice that have broken and shifted. In some regions, liquid water or slushy ice may have welled up from below, filling the gaps before freezing solid. The reddish-brown color of many of these features may come from salts or organic compounds brought up from the ocean, altered by radiation from Jupiter. It is a surface that records the interaction between ice and water, between the frozen exterior and the liquid interior. Europa is one of the most promising places in the solar system to search for life. The ocean beneath the ice is not just water. It is in contact with a rocky sea floor, where minerals and heat could provide the ingredients for life. On Earth, similar environments exist in the deep ocean, far from sunlight, where life thrives around hydrothermal vents. These ecosystems rely on chemical energy rather than photosynthesis, and they show that life can exist in darkness, in cold, in places that seem utterly inhospitable. Europa's ocean may have similar conditions. Warm water circulating through the rocky mantle could create hydrothermal systems, releasing nutrients and energy into the water. If life exists there, it would be simple, likely microbial, but it would be life nonetheless, a second origin, independent of Earth. The surface of Europa is one of the most hostile places imaginable. It is bombarded by intense radiation from Jupiter's magnetosphere, a relentless barrage of high-energy particles that would be lethal to any life on the surface. The temperature hovers around -160 degrees Celsius, cold enough to freeze carbon dioxide. There is no atmosphere to speak of, just a trace of oxygen produced when radiation breaks apart water molecules on the ice. Any organism on the surface would be destroyed almost instantly. But beneath the ice, shielded from radiation, insulated from the cold, the ocean is a different world. Dark, yes. Isolated, yes. But possibly habitable. If a probe could drill through the ice and reach the ocean, it would enter a realm no human eye has ever seen. A vast, dark sea, lit only by the faint glow of whatever equipment descended into it. The water would be cold but not frozen, kept liquid by the heat rising from the rocky core. The ocean might be still, or it might have currents, driven by the moon's slow rotation and the pull of Jupiter's gravity. The seafloor could be smooth, covered in sediment, or it could be rough, studded with hydrothermal vents, releasing plumes of warm, mineral-rich water. If life is there, it might cling to the rocks near these vents, or drift through the water, or form mats on the underside of the ice. It is a mystery waiting to be solved, a question that pulls at the imagination. What lives in the ocean of Europa? Titan is the only moon with a thick atmosphere. Orbiting Saturn, far from the Sun, Titan is shrouded in a dense orange haze. Its atmosphere is thicker than Earth's, composed mostly of nitrogen with traces of methane and other hydrocarbons. This atmosphere is so opaque that the surface is invisible to the naked eye, hidden beneath layers of smog. When the Cassini spacecraft arrived at Saturn, it carried the Huygens probe, which descended through Titan's atmosphere and landed on the surface. The images it sent back revealed a world unlike any other. A landscape of dark plains, pale highlands, and channels carved by flowing liquid. Not water, but methane. On Titan, methane plays the role that water plays on Earth. It evaporates from lakes and seas, rises into the atmosphere, condenses into clouds, and falls as rain. This rain carves rivers and valleys, erodes the landscape, and fills lakes and seas. The surface is shaped by the same processes that shape Earth: erosion, deposition, weathering, but with a completely different chemistry. The lakes are methane and ethane, cold enough at -179 degrees Celsius to remain liquid. The rocks are water ice, as hard as granite in Titan's cold. The sand is made of organic particles, grains of hydrocarbons that settle from the atmosphere. It is a hydrocarbon world, a place where organic chemistry runs wild. The largest body of liquid on Titan is Kraken Mare, a sea larger than the Caspian Sea on Earth. It sits near Titan's north pole, a dark expanse of liquid methane and ethane, dotted with islands and bordered by rugged coastlines. Radar images from Cassini show waves on its surface, driven by winds in Titan's atmosphere. The depth is unknown, but it could be hundreds of meters deep, a true sea on an alien world. There are other seas and lakes nearby, Ligeia Mare, Punga Mare, and dozens of smaller lakes, each one a reservoir of liquid hydrocarbons. These are the only stable bodies of liquid on the surface of any world other than Earth. The surface of Titan is remarkably smooth in some places, covered in plains of dark, fine-grained material. In other areas, there are dunes, long parallel ridges of sand-like particles blown by the wind. These dunes are enormous, up to 100 meters tall and stretching for hundreds of kilometers. They are made of organic particles, the complex hydrocarbons that form in Titan's atmosphere and rain down onto the surface. The dunes show that Titan has weather, not just rain, but wind, and the wind is strong enough to move material across the surface. It is a dynamic world, shaped by the same forces that shape Earth, but working with completely different materials. Beneath Titan's surface, there may be another ocean, not methane this time, but water. Scientists believe that beneath the icy crust, deep below the lakes and seas, there is a layer of liquid water mixed with ammonia. This subsurface ocean is thought to be global, wrapping around the entire moon. It is kept liquid by heat from the moon's interior, generated by the decay of radioactive elements, and possibly by tidal heating from Saturn. This hidden ocean could be tens of kilometers deep, another potential habitat for life. If it exists, it would be completely isolated from the surface, separated by a thick shell of ice. But it would be liquid, and where there is liquid water, there is the possibility of life. Titan is the only place in the solar system, other than Earth, where rain falls and pools on the surface. This makes it unique, a world with a hydrological cycle, with weather, with seasons. Because Saturn's orbit is elliptical and tilted, Titan experiences seasonal changes. The lakes and seas shift between the hemispheres as the seasons change, with more liquid accumulating in the summer hemisphere. Clouds form and dissipate, storms erupt and fade. It is a world in motion, a world with a climate, a world that changes over time. And all of this happens in near darkness, with the sun appearing as a dim, distant point in the hazy sky. If you could stand on the surface of Titan, the scene would be otherworldly. The sky would be a dull orange, the light filtered through the thick haze. The sun would be a pale disk, barely brighter than the moon seen from Earth. The landscape would be dim, lit by the faint glow of the distant sun, the light refracted and scattered by the atmosphere. The ground would be dark, covered in organic sands and pebbles of ice. In the distance, you might see the shore of a methane lake, its surface smooth and glassy, reflecting the orange sky. The air would be cold, far colder than any place on Earth, and thick, pressing down with a pressure 1.5 times that of Earth's atmosphere. It would be quiet, except for the faint whisper of wind and the occasional patter of methane rain. Enceladus sprays water into space. Orbiting Saturn, tucked among the inner moons, Enceladus is a small, icy world, bright and reflective. Its surface is covered in fresh ice, so bright that it reflects nearly all the sunlight that hits it. In some regions, the surface is smooth and crater-free, indicating recent geological activity. In others, there are fractures and ridges, signs of tectonic forces at work. But the most remarkable feature of Enceladus is found at its south pole. There, in a region called the Tiger Stripes, the moon is split by deep, warm fractures that spew jets of water vapor and ice particles into space. These jets are spectacular. They rise from the fractures in towering plumes, some reaching hundreds of kilometers above the surface. The particles are mostly water ice, but they also contain salts, organic compounds, and traces of other materials. Some of the particles fall back onto the surface, creating a fresh coating of ice. Others escape into space, feeding Saturn's faint E-ring, a diffuse band of ice particles that encircles the planet. The discovery of these jets was one of the most exciting findings of the Cassini mission. It showed that Enceladus is not a dead, frozen world, but an active one, with something happening beneath the ice. The jets come from a subsurface ocean. Like Europa, Enceladus hides a global ocean beneath its icy shell. The ocean is in contact with the moon's rocky core, and the water is warm, heated by tidal forces as Enceladus orbits Saturn. The tiger stripe fractures are cracks in the ice shell that reach down to the ocean below. When the ocean water is forced up through these cracks, it flashes into vapor in the vacuum of space, creating the jets we see. The fact that the water is in contact with rock is significant. It means there could be hydrothermal activity, chemical reactions that could provide energy for life. Cassini flew through the plumes and sampled their composition. It found organic molecules, complex carbon-based compounds that are the building blocks of life. Enceladus is one of the brightest objects in the solar system. Its surface reflects so much sunlight that it is almost blinding when viewed up close. The reason is the constant resurfacing by fresh ice from the jets. As the particles fall back onto the moon, they create a pristine, white surface, unmarred by dust or radiation damage. The ice is pure, crystalline, and it covers the entire moon. Even the older regions, those with a few craters, are still bright because the ice does not darken significantly over time. This makes Enceladus easy to spot among Saturn's moons, a tiny, brilliant jewel in the darkness. The tiger stripes are warmer than the surrounding terrain. Infrared observations show that the fractures are tens of degrees warmer than the rest of the surface, a sign that heat is escaping from the interior. This heat is generated by tidal flexing, the same process that drives Eo's volcanoes and Europa's ocean. As Enceladus orbits Saturn, the gravitational pull of the planet stretches and compresses the moon, generating friction and heat. Most of this heat is concentrated at the South Pole, where the tiger stripes are located. The fractures act like pressure relief valves, allowing the heat and water to escape. It is a small moon, but it is surprisingly active, a world where the forces of gravity and heat create dynamic, ongoing processes. If a spacecraft could land on Enceladus and drill through the ice, it would enter a hidden ocean, a dark sea, warmed by hydrothermal vents. The ocean is estimated to be 10 kilometers deep, lying beneath a shell of ice, perhaps 30 kilometers thick. The water is salty, similar to Earth's oceans, and it contains the raw materials for life. On Earth, hydrothermal vents support entire ecosystems teeming with life that relies on chemical energy rather than sunlight. The same could be true on Enceladus. The ocean could harbor simple organisms, microbes that thrive in the warm, mineral-rich water near the vents. It is one of the best candidates for finding life beyond Earth, a tiny moon with a hidden, potentially habitable world. Triton orbits Neptune backward. Most moons orbit their planets in the same direction that the planet rotates. This is the natural outcome of the way moons form, condensing from the disk of material that surrounds a young planet. But Triton is different. It orbits Neptune in the opposite direction, a retrograde orbit that suggests it did not form there. Instead, Triton is thought to be a captured object, a dwarf planet from the Kuiper belt that wandered too close to Neptune and was snared by the planet's gravity. This capture would have been a violent event, disrupting Triton's original orbit and possibly destroying any other moons Neptune once had. Triton is the largest moon orbiting Neptune, and it is the coldest known surface in the solar system. Temperatures on Triton can drop to minus 235 degrees Celsius, just a few degrees above absolute zero. At this temperature, nitrogen freezes solid, and the surface is covered in nitrogen ice mixed with frozen methane and water. Despite the extreme cold, Triton is geologically active. Voyager 2, the only spacecraft to visit Neptune, discovered geysers on Triton's surface, plumes of nitrogen, gas, and dark material shooting up to 8 kilometers into the thin atmosphere. These geysers are driven by solar heating, even though the sun is faint and distant at Neptune's orbit. The sunlight warms the subsurface ice, causing pockets of nitrogen to sublimate and burst through the surface. The surface of Triton is unlike any other moon. Much of it is covered in a smooth, bright plains called cantaloupe terrain, named for its resemblance to the skin of a melon. This terrain is covered in ridges and depressions, a pattern that suggests the surface has been reshaped by processes deep below. There are also dark streaks, likely created by the geysers, which deposit dark organic material onto the ice. The surface is young, with few craters, indicating that geological activity has erased most of the impact scars. Some regions are wrinkled and folded, showing signs of tectonic forces. It is a complex, fascinating landscape, shaped by cold and pressure and time. Triton is slowly spiraling inward toward Neptune. The retrograde orbit means that tidal forces are slowing Triton down rather than speeding it up. Over millions of years, this will cause the Moon to drift closer to the planet. Eventually, in a few billion years, Triton will cross the Roche limit, the distance at which tidal forces become stronger than the Moon's own gravity. When that happens, Triton will be torn apart, shredded into pieces that will form a spectacular ring around Neptune. This is a slow, inevitable process, a reminder that even the moons themselves are not permanent. They are shaped by time and gravity, and their fates are written in the mechanics of their orbits. Triton has a thin atmosphere, composed mostly of nitrogen with traces of methane. This atmosphere is incredibly tenuous, barely more than a whisper, but it is enough to support clouds and haze. Voyager 2 detected a layer of haze above the surface, created by the sunlight breaking apart methane molecules and forming complex organic compounds. These compounds condense into tiny particles that drift through the atmosphere, scattering light and creating a faint veil. The atmosphere is slowly escaping into space, stripped away by the solar wind and Neptune's magnetic field. Over time, Triton is losing its atmosphere, molecule by molecule, until one day it may be gone entirely. If you could visit Triton, you would find a world of frozen beauty. The surface would be bright and smooth in some places, textured and wrinkled in others. The sky would be dark, with Neptune hanging overhead, a massive blue sphere filling the heavens. The sun would be a distant, cold point of light, barely warming the landscape. The geysers would erupt intermittently, dark plumes rising against the pale ice, drifting slowly in the thin atmosphere before settling back to the surface. It would be silent, or nearly so, with no wind to speak of, no sound except perhaps the faint crackle of sublimating ice. It would be a place of stillness and cold, a moon at the edge of the solar system, orbiting backward, slowly falling toward its eventual destruction. Ganymede is the largest moon in the solar system. Larger than the planet Mercury, Ganymede is a giant among moons, a world that rivals the planets themselves. It orbits Jupiter, the outermost of the 4 Galilean moons, and it is a study in contrasts. The surface is divided into 2 types of terrain: dark regions covered in ancient, heavily cratered ice, and bright regions crisscrossed by ridges and grooves. The dark terrain is old, dating back billions of years, scarred by countless impacts. The bright terrain is younger, formed by tectonic activity that fractured and reshaped the surface. These bright regions are lighter in color because they are covered in fresh ice, exposed by the tectonic processes that created them. Ganymede has its own magnetic field, the only moon in the solar system known to have one. This magnetic field is generated by a liquid iron core deep within the moon, a sign that Ganymede is differentiated, with layers of rock and metal separated by gravity. The magnetic field creates a magnetosphere, a bubble of protection around the moon that shields it slightly from Jupiter's intense radiation. This magnetosphere is small and weak compared to a planet's, but it is remarkable nonetheless, a sign that Ganymede is more than just a ball of ice and rock. It is a complex world with a dynamic interior. Beneath Ganymede's icy crust, there may be an ocean, or perhaps several layers of oceans, separated by layers of ice. The evidence comes from observations of the magnetic field and the way the surface behaves. The ocean is thought to be salt water, kept liquid by heat from the Moon's interior. Unlike Europa's ocean, which is relatively close to the surface, Ganymede's ocean is deep, buried beneath perhaps 150 kilometers of ice. This makes it much harder to access, but it also means it is insulated, protected from the radiation and cold of space. The ocean could be tens of kilometers deep, another hidden sea, another potential home for life. The surface of Ganymede tells a story of violence and change. The dark terrain is covered in craters, evidence of the heavy bombardment that occurred early in the solar system's history. The bright terrain, by contrast, is less cratered, showing that it formed more recently. The grooves and ridges in the bright terrain suggest that the surface has been stretched and pulled, possibly by tidal forces or by the expansion of the interior as it cooled. Some of these grooves are hundreds of kilometers long, parallel lines that cut across the landscape. They are a record of the forces that have shaped Ganymede over billions of years, a testament to the Moon's complex history. Ganymede's size gives it a strange duality. It is large enough to be considered a planet if it orbited the Sun directly. Yet, it is classified as a moon because it orbits Jupiter. This raises interesting questions about what defines a planet or a moon. Is it the size, the composition, the orbit, or something else? Ganymede has more in common with some planets than it does with smaller moons. It has a magnetic field, a differentiated interior, geological activity, and possibly an ocean. In many ways, it is a world unto itself, a planet in all but name, tethered to Jupiter by gravity. If a human could stand on Ganymede, they would see a landscape of ice and rock, ancient craters and fresh ridges, dark plains and bright valleys. The sky would be black, dotted with stars, and dominated by Jupiter, hanging in the sky like a colossal lantern. The surface would be cold, frozen solid, and bathed in radiation from Jupiter's magnetosphere. The horizon would be distant, curving gently away, a reminder of the Moon's size. It would be a place of stark beauty, a world caught between moon and planet, ancient and active, dead and alive, all at once. Mimas looks like the Death Star. Orbiting Saturn, Mimas is a small, icy moon, heavily cratered and unremarkable in most ways. But it has one feature that makes it famous: a giant impact crater called Herschel, which dominates one side of the Moon. The crater is so large that it gives Mimas an uncanny resemblance to the Death Star from Star Wars, complete with a circular depression that looks like the superweapon's focusing dish. Herschel is 130 kilometers across, nearly a third the diameter of Mimas itself. The impact that created it must have been catastrophic, nearly shattering the Moon. The walls of the crater are steep, rising 6 kilometers above the floor, and at the center is a peak almost as tall, formed by the rebound of material after the impact. The impact that created Herschel sent shockwaves through Mimas. On the opposite side of the Moon, there are fractures and cracks, evidence that the energy of the impact traveled through the entire body. These fractures are a reminder of how fragile small moons can be. A slightly larger impact, or one at a different angle, might have destroyed Mimas entirely, scattering it into fragments. Instead, the Moon survived, though it bears the scar of that ancient collision. Herschel is a testament to the violence of the early solar system, when impacts were common and moons were regularly battered by asteroids and comets. Despite its dramatic appearance, Mimas is geologically dead. There are no signs of tectonic activity, no geysers, no internal heat. The surface is old and cratered, unchanged for billions of years. The Moon is too small to retain much heat, and any warmth it once had has long since radiated away into space. It is a frozen, inert world, a relic of the past. The only thing that distinguishes Mimas from countless other small moons is the size and prominence of Herschel crater. Without it, Mimas would be just another icy rock, unremarkable and forgotten. Mimas orbits close to Saturn, within the planet's ring system. It is the smallest known body in the solar system that is round, pulled into a spherical shape by its own gravity. Anything smaller tends to be irregular, shaped more by impacts and structure than by gravity. Mimas sits right at the boundary, a transition between moon and rubble. Its proximity to Saturn means it is embedded in the planet's gravitational field, and it plays a role in shaping the rings. The gravitational influence of Mimas creates a gap in the rings called the Cassini division, a dark band that separates the A and B rings. This gap is carved by resonances, places where particles in the ring orbit at specific ratios to Mimas's orbit, and the repeated gravitational tugs eject them from that region. If a visitor could travel to Mimas and stand on its surface, near the edge of Herschel crater, they would look up at walls of ice towering kilometers above them. The floor of the crater would stretch away in all directions, a vast circular plain, and at the center, the peak would rise like a mountain. Beyond the crater rim, the rest of the moon would be visible, a patchwork of smaller craters, ridges, and valleys. In the sky, Saturn would loom enormous, its rings stretching from horizon to horizon, a breathtaking sight. The rings would be so close that individual gaps and divisions would be visible, and the sunlight filtering through them would create patterns of light and shadow on the surface. It would be a silent, frozen world, but the view would be unforgettable. Phobos is slowly falling into Mars. Mars has two moons, Phobos and Deimos, both small, irregular, and heavily cratered. Phobos is the larger of the two, though it is still tiny by moon standards, just 27 kilometers across at its widest point. It orbits Mars at an altitude of only about 6,000 kilometers, closer to its planet than any other moon in the solar system. This proximity means that Phobos moves fast, orbiting Mars 3 times a day. From the surface of Mars, Phobos would appear to rise in the west and set in the east, the opposite of the Sun, a strange and unsettling sight. But Phobos is not going to orbit Mars forever. Tidal forces are slowing it down, causing it to spiral inward toward the planet. Every century, Phobos drops about 2 meters closer to Mars. This may not sound like much, but over millions of years, it adds up. In about 50 million years, Phobos will cross the Roche limit, the point at which Mars's gravity will tear it apart. When that happens, Phobos will disintegrate, shredded into a ring of debris that will encircle the planet. Mars will gain a ring system, and Phobos will cease to exist as a moon. It is a slow death, but an inevitable one, written in the mathematics of orbits and gravity. Phobos is covered in craters, the scars of countless impacts over billions of years. The largest crater is Stickney, nearly 9 kilometers across, almost half the diameter of the moon itself. The impact that created Stickney must have come close to destroying Phobos entirely. The force of the collision sent fractures radiating across the surface, visible as grooves and ridges. These grooves are one of the mysteries of Phobos. Some of them line up with Stickney, suggesting they were created by the impact. Others do not, and their origin is unclear. They may be caused by tidal stresses, as Phobos orbits Mars, or they may be related to the loose, rubble-like structure of the moon. Phobos is not a solid rock, but a collection of fragments held together by gravity, a rubble pile in space. The surface of Phobos is dark and dusty, covered in a layer of loose material called regolith. This regolith is the result of billions of years of impacts, which have shattered and pulverized the surface into fine dust and gravel. The dust is so fine that it behaves almost like a fluid, shifting and flowing with every disturbance. Footprints on Phobos, if anyone ever walked there, would be deep and soft, sinking into the dust. The gravity is so weak, less than 1,000th of Earth's, that a person could easily jump off the surface and into orbit. Escaping Phobos would require a velocity of only about 11 meters per second, slow enough that a strong person could achieve it by running and jumping. If a human could visit Phobos, the experience would be surreal. The horizon would be close, just a few kilometers away, and the surface would curve sharply, a reminder of the moon's small size. Mars would fill half the sky, a massive red sphere, its features, craters, volcanoes, canyons, visible in stunning detail. The sun would be smaller and dimmer than on Earth, a pale disk in the black sky. The surface would be rough and cratered, covered in dust and rocks, and every step would send up a slow-motion cloud of particles that would take minutes to settle in the weak gravity. It would be a place of extremes, a tiny, fragile world, caught in a slow spiral toward its destruction, orbiting a planet that will one day consume it. Hyperion is a chaotic tumbler. Most moons rotate in a predictable, regular way, spinning at a constant rate as they orbit their planet. But Hyperion, a moon of Saturn, does not. It tumbles chaotically, its rotation changing unpredictably over time. This chaotic rotation is caused by Hyperion's irregular shape and its proximity to Titan, Saturn's largest moon. Hyperion is not round, but potato-shaped, covered in craters and ridges, and its uneven mass distribution makes it unstable. Titan's gravity tugs on Hyperion as it passes, adding further chaos to its rotation. The result is a moon that spins and tumbles in a way that is impossible to predict, a body that never settles into a stable pattern. The surface of Hyperion is one of the strangest in the solar system. It is covered in craters, but these craters are not like those on other moons. They are deep and sharp, with steep walls and flat floors, giving the surface a sponge-like appearance. This texture is caused by the moon's low density and porous structure. Hyperion is not a solid body, but a loose collection of ice and rock, with a lot of empty space inside. When impacts occur, they do not compact the surface as they would on a denser body. Instead, they excavate deep holes, creating the distinctive appearance. The surface is also very dark in places, covered in a layer of dark material that may be organic compounds or dust from impacts. Hyperion is one of the largest irregular moons in the solar system. Most large moons are round, pulled into a spherical shape by their own gravity. But Hyperion is too small and too porous for this to happen. Its shape is irregular, elongated, and its mass is low, only about half the density of water ice. This suggests that Hyperion is more like a rubble pile than a solid rock, a collection of fragments loosely held together by gravity. It may have formed from the debris of a larger moon that was shattered by an impact, or it may be a primordial object that never fully coalesced into a solid body. The chaotic rotation of Hyperion makes it difficult to study. Because it tumbles unpredictably, any observations of the surface are essentially snapshots, showing different regions at different times. There is no way to predict what part of the moon will be facing the sun or a spacecraft at any given moment. This makes it challenging to map the surface or understand the moon's geology. The Cassini spacecraft made several close flybys of Hyperion, capturing detailed images of the sponge-like surface and measuring the moon's mass and density. These observations confirmed that Hyperion is a strange, unique object unlike any other moon in the solar system. If a visitor could somehow land on Hyperion, the experience would be disorienting. The surface would be rough and uneven, covered in deep craters and sharp ridges. The gravity would be incredibly weak, making it easy to float off the surface with the slightest push. The horizon would be close, and the shape of the moon would be obvious, a lumpy, irregular object. Saturn would be visible in the sky, but because of Hyperion's chaotic rotation, the planet would appear to move in unpredictable ways, rising and setting at irregular intervals. The sun would wheel across the sky in a pattern that never repeated. It would be a place of confusion and disorientation, a moon that refuses to follow the rules, a body that tumbles endlessly through space. Miranda is a patchwork moon. Orbiting Uranus, Miranda is one of the most visually striking moons in the solar system. Its surface is a bizarre mix of terrains, with old, heavily cratered regions sitting next to young, ridged, and grooved areas. There are cliffs so tall they dwarf anything on Earth, canyons deeper than the Grand Canyon, and strange, chevron-shaped features that look like they were carved by some unknown process. The variety and contrast of these terrains suggest that Miranda has been geologically active in the past, reshaped by internal forces that have long since died away. The most dramatic feature on Miranda is Verona Rupes, the tallest known cliff in the solar system. It rises about 20 kilometers above the surrounding terrain, a sheer wall of ice and rock. If you fell from the top of Verona Rupes, you would take about 12 minutes to hit the bottom, thanks to Miranda's weak gravity. The fall would be slow and eerie, with plenty of time to watch the surface approaching. The cliff is thought to have formed from tectonic activity, perhaps as the moon's surface cracked and shifted under the influence of tidal forces from Uranus. It is a scar from a time when Miranda was more active, when heat flowed through its interior and reshaped the surface. Miranda's strange surface may be the result of a catastrophic impact. One theory is that Miranda was once shattered by a collision, broken into pieces that later reaccreted, reassembling into the moon we see today. This would explain the patchwork appearance, with different terrains representing different fragments that came back together. Another theory is that Miranda experienced periods of intense tidal heating, similar to Io or Enceladus, which melted parts of the interior and drove geological activity. When the heating stopped, the moon froze, locking the strange terrains into place. Either way, Miranda is a record of violence and change, a moon that has been through something dramatic and survived. The surface of Miranda is a mix of old and new, light and dark, smooth and rough. Some regions are bright and heavily cratered, ancient surfaces that have remained unchanged for billions of years. Others are dark and grooved, with parallel ridges and valleys that suggest tectonic forces at work. There are also coronae, large oval-shaped features surrounded by ridges and grooves, which may have formed when warm ice rose from the interior and reshaped the surface. These coronae are unique to Miranda, and their origin is still debated. Miranda orbits Uranus at a distance of just 130,000 kilometers, close enough that the planet would dominate the sky. Uranus is unusual among planets because its axis is tilted almost on its side, so the planet appears to roll through space rather than spin upright. This means that Miranda's orbit is also tilted, and the moon experiences extreme seasonal changes as Uranus orbits the sun. For part of the orbit, one pole of Miranda is in constant sunlight, while the other is in darkness. Then, the situation reverses. This cycle repeats every 42 years, the length of Uranus's orbital period. The result is a moon with bizarre, extreme seasons, where the sun barely moves in the sky for years at a time. If a person could visit Miranda, they would find a world of stark contrasts. Towering cliffs, deep canyons, smooth plains, and rugged highlands, all packed into a moon just 470 kilometers across. The gravity would be weak, less than 1% of Earth's, making it easy to move, but also easy to accidentally launch yourself off the surface. The sky would be dominated by Uranus, a pale blue-green sphere, featureless and strange. The sun would be a distant, dim point of light, barely warm enough to notice. it would be a cold, silent place, a moon frozen in time, a record of ancient violence and change. Iapetus has two faces. Orbiting Saturn, Iapetus is a moon of stark contrasts. One hemisphere is as bright as snow, covered in fresh, white ice. The other is as dark as asphalt, coated in a mysterious dark material. This two-toned appearance makes Iapetus one of the most visually distinctive moons in the solar system. When Cassini flew past, it captured stunning images of the boundary between the bright and dark regions, a sharp line where the two terrains meet. The bright side, called the trailing hemisphere, is pristine ice, reflecting sunlight brilliantly. The dark side, called the leading hemisphere, absorbs almost all light, making it one of the darkest surfaces in the solar system. The origin of the dark material is still debated. One theory is that it comes from outside Iapetus, dust from a distant moon or ring that slowly spirals inward and coats the leading hemisphere. Another theory is that the dark material comes from inside the moon, brought to the surface by cryovolcanism or impacts. A third theory suggests that the dark material is created by a feedback loop. The dark surface absorbs sunlight, heats up slightly, and causes water ice to sublimate. The ice leaves behind a darker residue which absorbs even more light, creating more sublimation, and so on. Over millions of years, this process darkens one hemisphere while the other remains bright. Iapetus has another unusual feature, a massive ridge that runs along its equator. This ridge is about 20 kilometers wide and 13 kilometers high, stretching for over 1,300 kilometers. It is one of the most bizarre features in the solar system, a wall of mountains circling the moon like a seam. The ridge gives Iapetus the appearance of a walnut, with the ridge standing out prominently against the surface. The origin of the ridge is unknown. Some scientists think it formed when Iapetus was rotating faster, and centrifugal forces pushed material outward at the equator. Others think it is the remnant of a ring that collapsed onto the surface. It remains a mystery, a strange scar that hints at a violent or unusual past. Iapetus is one of the largest moons of Saturn, with a diameter of about 1,470 kilometers. It orbits far from the planet, out beyond the main ring system, in a region where tidal forces are weak and the moon is relatively isolated. This isolation means that Iapetus has not been reshaped by tidal heating like some of Saturn's inner moons. Its surface is ancient, covered in craters that date back billions of years. The moon is also not quite round. It is slightly flattened, as if it froze in place while it was spinning faster than it does now. This suggests that Iapetus once rotated more quickly, and over time, tidal forces slowed it down, locking it into its current rotation. If a visitor could stand on Iapetus, the view would be extraordinary. The surface would be either blindingly bright or deeply dark, depending on which hemisphere they were on. The boundary between the two would be visible in the distance, a sharp line dividing light from dark. The equatorial ridge would rise on the horizon, a towering wall of mountains stretching across the landscape. Saturn would be visible in the sky, but small and distant, a pale yellow disk with faint rings. The sun would be tiny, far smaller than it appears from Earth, and the light would be dim. It would be a place of extremes, a moon divided, a world of light and shadow, ancient and unchanging. Charon is Pluto's partner. Unlike most moons, which are much smaller than the planets they orbit, Charon is large enough that it and Pluto form a binary system. They do not orbit a point inside Pluto. Instead, they orbit a point in space between them, a shared center of gravity. This makes Charon more of a partner than a moon, and the two are locked in a tidal embrace, always showing the same face to each other. Charon is about half the diameter of Pluto and 1/8 its mass, making it one of the largest moons relative to its planet in the solar system. Charon's surface is ancient and heavily cratered, but it also has strange features that suggest geological activity. There are canyons and cliffs, signs that the surface has cracked and shifted. There is also a dark polar cap, a region around the North Pole covered in reddish-brown material. This material is thought to be organic compounds, created when methane from Pluto's atmosphere freezes onto Charon's surface and is altered by solar radiation. The result is a coating of tholins, complex organic molecules that give the polar cap its distinctive color. The most striking feature on Charon is a massive canyon system that stretches across the moon's surface. This canyon is longer and deeper than any canyon on Earth, cutting through the ice and rock and creating a dramatic scar. The canyon may have formed when Charon's interior froze and expanded, cracking the surface. Or it may be related to tidal forces from Pluto, which would have been stronger in the past when the two bodies were closer together. Either way, the canyon is evidence that Charon has been geologically active, reshaped by internal forces that have since died away. Charon and Pluto are tidally locked to each other, meaning they always show the same face to one another. This is the result of billions of years of tidal interactions, which have gradually slowed their rotations until they match their orbital periods. From the surface of Pluto, Charon would appear to hang in the same spot in the sky, never rising or setting. From Charon, Pluto would do the same. This mutual tidal lock is rare in the solar system, and it makes the Charon-Pluto system unique. The two worlds are bound together, partners in a slow, eternal dance. If a person could stand on Charon, they would see Pluto hanging in the sky, a large, colorful sphere with bright plains and dark regions. Pluto would never move, fixed in place by the tidal lock. The sun would be a tiny, distant point of light, barely brighter than other stars. The surface of Charon would be rough and icy, covered in craters and canyons, and the horizon would be close, curving away sharply. The sky would be black, filled with stars, and the Milky Way would stretch overhead in a brilliant arc. It would be a place of stillness and silence, a moon and a planet locked together, orbiting the sun in the far reaches of the solar system. Dactyl orbits an asteroid. Most moons orbit planets, but a few orbit asteroids instead. Dactyl is one of these, a tiny moon just 1.5 kilometers across, orbiting the asteroid Ida. Dactyl was discovered by the Galileo spacecraft in 1993 as it flew past Ida on its way to Jupiter. It was the first moon of an asteroid ever found, and its discovery changed our understanding of the solar system. If asteroids can have moons, then moons can be found almost anywhere, orbiting bodies large and small throughout the solar system. Dactyl is a small, irregular object, heavily cratered and composed mostly of rock. It orbits Ida at a distance of about 90 kilometers, circling the asteroid once every 20 hours. The orbit is slow and lazy, and the gravity holding Dactyl in place is incredibly weak. A person standing on Dactyl could probably jump hard enough to escape its gravity entirely. The discovery of Dactyl suggests that many asteroids may have moons, small companions captured by gravity or formed from debris during impacts. Since Dactyl's discovery, dozens of other asteroid moons have been found. Some asteroids have one moon, others have two or even more. These moons are usually small and irregular, fragments of rock or ice held in place by the weak gravity of their parent body. They orbit slowly and distantly, and they are often discovered by accident during flybys or observations intended for other purposes. The existence of these moons tells us that the solar system is full of small, overlooked bodies, moons and asteroids and debris, all orbiting and interacting in complex ways. If a visitor could travel to Dactyl, they would find a tiny, barren world, a fragment of rock tumbling through space. The surface would be rough and cratered, and the horizon would be close, just a few hundred meters away. Ida would be visible in the sky, a large, irregular shape, slowly rotating. The gravity would be almost non-existent, and any movement would send the visitor floating gently away from the surface. The sun would be smaller and dimmer than on Earth, and the sky would be black and filled with stars. It would be a lonely place. A tiny moon orbiting a tiny asteroid, both of them orbiting the sun in the vast emptiness of space. The moons of Pluto are a chaotic system. Pluto has 5 known moons: Charon, Styx, Nix, Kerberos, and Hydra. While Charon is large and stable, the 4 smaller moons orbit in a complex, chaotic way. They tumble unpredictably, their rotations changing over time, influenced by the gravitational pull of Pluto and Charon. The system is so chaotic that it is impossible to predict the exact orientation of the small moons from one orbit to the next. They spin and tumble in response to the gravitational tug-of-war between Pluto and Charon, never settling into a stable pattern. The small moons of Pluto are thought to have formed from debris left over after a massive impact. Billions of years ago, a large object may have collided with Pluto, blasting material into orbit. This material coalesced into Charon and the smaller moons, creating the system we see today. The small moons are irregular in shape, covered in ice, and highly reflective. They orbit far from Pluto, outside Charon's orbit, in a region where their paths are influenced by both bodies. The result is a dynamic, ever-changing system where the moons never quite settle down. Observing the small moons of Pluto is challenging. They are tiny, faint, and far away, visible only with the most powerful telescopes. The New Horizons spacecraft, which flew past Pluto in 2015, captured the best images we have of these moons. The images show that they are small, bright, and irregular, with surfaces that reflect a lot of sunlight. The exact shapes and features of the moons are still uncertain, but they appear to be fragments, pieces of a larger body that was shattered and reformed. If a person could visit one of the small moons, say Nix or Hydra, they would find a tiny, icy world tumbling through space. The surface would be rough and cratered, and the gravity would be so weak that walking would be impossible. Instead, they would float above the surface, held in place only by the gentlest of forces. Pluto and Charon would be visible in the sky, 2 bodies locked together, orbiting a shared center of gravity. The sun would be a distant, cold point of light, and the sky would be filled with stars. It would be a place of silence and stillness, a tiny moon at the edge of the solar system, orbiting a dwarf planet, part of a chaotic, beautiful dance. The shepherd moons guide Saturn's rings. Saturn's rings are one of the most beautiful sights in the solar system, but they are not just random bands of ice and rock. They are shaped and maintained by small moons called shepherd moons. These moons orbit just inside or outside the rings, and their gravity keeps the ring particles in line. When a ring particle drifts too far, the gravity of the shepherd moon nudges it back into place. This constant interaction carves gaps in the rings, creates sharp edges, and maintains the structure that makes Saturn's rings so distinct. 2 of the most famous shepherd moons are Prometheus and Pandora, which orbit on either side of Saturn's F-ring. The F-ring is narrow and braided, with twists and kinks that change over time. Prometheus and Pandora are responsible for this structure. Their gravity pulls on the ring particles, creating waves and ripples, and occasionally dragging out long streamers of material. The F-ring is dynamic, constantly changing, and the shepherd moons are the sculptors, shaping it with their gravity. Other shepherd moons include Pan and Daphnis, which orbit inside gaps in Saturn's rings. Pan orbits in the Encke Gap, a division in the A ring, and Daphnis orbits in the Keeler Gap, a narrower division farther out. These moons are small, just tens of kilometers across, but their gravity is enough to clear the gaps they occupy. Images from Cassini show that these moons have accumulated ring material around their equators, giving them a ridge-like appearance. They look like flying saucers, with a bulge around the middle, made from the ice and dust they have swept up from the rings. The shepherd moons are not large or massive, but they play a crucial role in maintaining Saturn's rings. Without them, the rings would gradually spread out and dissipate. The gravity of the shepherd moons keeps the rings confined, sharp-edged, and beautiful. They are the caretakers of the rings, invisible to most observers, but essential to the structure we see. If the shepherd moons were removed, the rings would slowly fade, losing their definition and clarity over millions of years. If a visitor could approach one of the shepherd moons, they would find a small, irregular object covered in ice and dust. The surface would be smooth in some places, where ring material has settled, and rough in others, where craters and ridges mark ancient impacts. The moon would be close to the rings, close enough that the rings would fill the sky, a vast, glowing band stretching from horizon to horizon. The individual particles in the rings would be visible, tumbling and glinting in the sunlight. Saturn would be nearby, a massive presence, its atmosphere swirling with storms and bands. It would be a place of beauty and motion, a tiny moon surrounded by the grandeur of Saturn's rings. The Martian moons may be captured asteroids. Phobos and Deimos, the two moons of Mars, are small, dark, and irregular. They do not look like typical moons. Instead, they resemble asteroids, rocky bodies with rough, cratered surfaces. This has led scientists to speculate that Phobos and Deimos are captured asteroids, objects that wandered too close to Mars and were snared by the planet's gravity. Their composition supports this idea. They are made of dark, carbon-rich material, similar to the asteroids found in the outer solar system. However, capturing an asteroid is not easy. For an asteroid to be captured by a planet, it must approach at just the right speed and angle, and there must be a way to slow it down so it does not escape back into space. One possibility is that Phobos and Deimos were slowed by passing through a disk of debris around early Mars, friction with the disk gradually slowing the asteroids until they were captured. Another possibility is that they formed from material ejected from Mars during a massive impact, similar to how Earth's moon is thought to have formed. The truth is still uncertain, and Phobos and Deimos remain a mystery. The surfaces of Phobos and Deimos are covered in a thick layer of dust and regolith, the result of billions of years of impacts. This dust is fine and dark, and it gives the moons their low reflectivity. Both moons are heavily cratered, with impact scars from small and large collisions. The largest crater on Deimos is about 2 kilometers across, and it dominates one side of the moon. Phobos, as mentioned earlier, has Stickney crater, a scar from an impact that nearly destroyed the moon. Deimos orbits farther from Mars than Phobos, at a distance of about 23,000 kilometers. It orbits slowly, taking just over 30 hours to complete one orbit. Unlike Phobos, which is spiraling inward, Deimos is slowly drifting outward, moving away from Mars over time. This outward drift is much slower than Phobos's inward spiral, and Deimos will remain a moon of Mars for billions of years. Eventually, though, it may escape Mars's gravity entirely, drifting off into space to become a free-floating asteroid once again. If a person could visit Deimos, they would find a quiet, dusty world, smaller and less dramatic than Phobos. The surface would be rough and cratered, covered in fine dust that would cling to everything. The gravity would be incredibly weak, even weaker than Phobos, and any movement would be slow and careful to avoid floating away. Mars would be visible in the sky, but smaller and less dominant than from Phobos, a pale red disk with dark markings and bright polar caps. The sun would be dim, and the sky would be black and starry. It would be a peaceful place, a tiny moon orbiting a quiet planet, far from the chaos and activity of the inner solar system. Saturn's moons are tidally locked to the planet. Most of Saturn's large moons, including Titan, Enceladus, Dione, Rhea, and Iapetus, are tidally locked to Saturn. This means they rotate at the same rate they orbit, so the same side always faces the planet. Tidal locking is the result of gravitational interactions over millions of years. The planet's gravity creates a bulge in the moon, and the friction from this bulge gradually slows the moon's rotation until it matches the orbital period. Once tidally locked, the moon remains in this state, with one side always facing the planet and the other side always facing away. This tidal locking affects the moons in interesting ways. The side facing Saturn is constantly bombarded by radiation and particles from the planet's magnetosphere. The side facing away is more shielded, exposed instead to the solar wind and cosmic rays. This creates asymmetries in the surface, with the leading hemisphere often darker and more heavily altered than the trailing hemisphere. The tidal locking also affects the moon's shape. The gravitational pull of Saturn creates a permanent bulge, stretching the moon slightly in the direction of the planet. For a human standing on a tidally locked moon, Saturn would always be in the same position in the sky. It would never rise or set, but would hang there, fixed, slowly going through phases as the moon orbited. On the side facing Saturn, the planet would dominate the sky, a massive presence, its rings stretching across the heavens. On the far side, Saturn would never be visible, hidden beyond the horizon. The sun would rise and set, and the stars would wheel overhead, but Saturn would remain constant, a reminder of the tidal forces that shape the moon. The tidal locking of Saturn's moons is a reminder of the power of gravity. Over time, gravity shapes not just the orbits of moons, but their rotations, their shapes, and even their surfaces. It is a slow, inexorable force, acting over millions and billions of years, creating order out of chaos, locking moons into stable, predictable patterns. The moons of Saturn and of Jupiter and of all the giant planets are testaments to this force, bodies shaped and held by the gravity of their planets, forever facing the worlds they orbit. The rings of Saturn may be the remnants of a destroyed moon. Saturn's rings are made of billions of particles of ice and rock, ranging in size from tiny grains to house-sized boulders. These particles orbit Saturn in a thin, flat disk, creating the stunning rings we see through telescopes. But where did the rings come from? One theory is that they are the remnants of a moon that was destroyed, either by a massive impact or by tidal forces. If a moon wandered too close to Saturn, the planet's gravity would have torn it apart, shredding it into pieces that spread out into a ring. Another theory is that the rings are leftover material from the formation of Saturn, debris that never coalesced into a moon. The rings are relatively young, perhaps only a few 100 million years old. This is surprisingly recent in the history of the solar system, which is over 4.5 billion years old. The evidence for this young age comes from the brightness and purity of the rings. They are made mostly of water ice, and they are very bright, reflecting a lot of sunlight. Over time, the rings should become darker, contaminated by dust and debris from micrometeoroids and comets. The fact that they are still bright suggests they formed relatively recently, within the last few 100 million years. If the rings are the remnants of a destroyed moon, that moon must have been large, perhaps similar in size to Mimas or Enceladus. The destruction of such a moon would have been catastrophic, a collision or tidal disruption that shattered the body and sent fragments spinning out into orbit. Over time, these fragments would have spread out, colliding and breaking apart, grinding down into the particles we see today. The rings are beautiful, but they are also a graveyard, the remains of a world that once existed and was destroyed. The rings of Saturn will not last forever. Over time, they are slowly spiraling inward toward the planet, pulled by gravity and atmospheric drag. Particles in the rings collide and lose energy, causing them to drift inward. Eventually, they will fall into Saturn's atmosphere, where they will vaporize. Scientists estimate that the rings will be gone in a few 100 million years, a blink of an eye in cosmic terms. Future generations, if they look at Saturn, will see a planet without rings, just a pale yellow sphere with a family of moons. The rings are temporary, a fleeting feature of the solar system, beautiful but not eternal. If a visitor could fly through Saturn's rings, they would see a vast, glittering expanse of ice and rock. The particles would be all around them, tumbling and spinning, reflecting sunlight in every direction. The rings are not solid, but a cloud of debris, and flying through them would be like flying through a snowstorm, except the snowflakes are made of ice and rock and traveling at incredible speeds. The gaps between the rings would be visible, dark bands where the particles have been cleared by the gravity of shepherd moons. Saturn would be nearby, a massive presence, its atmosphere swirling below. It would be a place of beauty and danger, a field of debris that stretches for hundreds of thousands of kilometers. And so, as we drift back from these distant, alien worlds, we find ourselves once again in the quiet of the night. We have journeyed far, to moons of fire and ice, to worlds with hidden oceans and towering cliffs, to tiny rocks tumbling through the void and vast bodies larger than planets. We have seen the strange and the beautiful, the violent and the serene. Each moon we visited tells a story, a fragment of the larger tale of how our solar system formed, how it evolved, and how it continues to change. These moons are not just cold, dead rocks. They are worlds, each with its own character, its own history. Some are still active, shaped by ongoing geological processes. Others are frozen in time, preserving records of the ancient past. Some may harbor life, hidden beneath ice or in subsurface oceans. Others are barren and lifeless, but no less remarkable for it. Together, they form a tapestry of diversity, a reminder that the universe is vast and filled with wonders, and that even in our own small corner of space, there is more strangeness and beauty than we can ever fully comprehend. As you lie here, feeling the weight of sleep beginning to settle over you, imagine these moons drifting through the darkness. Picture Europa's cracked ice, glowing faintly in the light of distant Jupiter. See Io's volcanoes erupting in silence, fountains of lava rising into the void. Envision Titan's methane lakes, still and dark, reflecting the hazy orange sky. Watch Enceladus's geysers spraying water into space, catching the sunlight and shimmering like diamonds. These are real places, out there, orbiting planets far from Earth, waiting to be explored, waiting to reveal their secrets. The solar system is not empty. It is full of life, not biological life, not yet that we know of, but dynamic life, the life of geology and weather, of tides and eruptions, of ice and fire. The moons are not static. They change, they evolve. They are shaped by the same forces that shaped Earth: gravity, heat, time. And they are part of the same story we are part of. The story of a solar system forming from a cloud of gas and dust, coalescing into planets and moons, evolving over billions of years into the system we see today. So, as your thoughts drift and your breathing deepens, let these images carry you into sleep. Let the quiet motion of moons orbiting planets lull you into rest. There is no need to hold on to any of this. It will still be there tomorrow and the next day, and for billions of years to come. The moons will continue their orbits, the geysers will continue to spray, the volcanoes will continue to erupt, and the hidden oceans will continue to churn beneath the ice. The universe does not wait for us, but it also does not rush. It simply is. Vast and patient, filled with wonders that unfold slowly, over timescales, longer than we can imagine. If you are still awake, if your mind is still turning these thoughts over, that is fine. There is no hurry. But if your eyes are heavy, if sleep is pulling at you, then let it come. Close your eyes. Let your body relax. Sink into the comfort of your bed, and let the images of distant moons carry you gently into dreams. Imagine yourself floating through space, drifting past these strange worlds, seeing them with your own eyes, feeling the silence and the stillness. It is a peaceful journey, and it leads to rest. The moons are waiting. They have been waiting for billions of years, and they will wait for billions more. There is no urgency, no need to understand everything right now. The universe is patient, and so too can you be. Let the mysteries remain mysteries for tonight. Let the questions go unanswered. There will be time for all of that later. For now, just rest. Just breathe. Just drift, like a moon orbiting a distant planet, moving slowly, gently, through the darkness. The atmosphere of Titan is a complex chemical factory. While we have talked about Titan's methane lakes and thick atmosphere, there is so much more happening in that orange haze. The atmosphere is not just nitrogen and methane. It contains complex organic molecules, hydrocarbons, that form when sunlight breaks apart methane molecules high in the atmosphere. These molecules combine and recombine, creating a smog of organic compounds that rain down onto the surface. Some of these compounds are the same building blocks that formed the first life on Earth. Titan is like a frozen laboratory, running chemistry experiments that may have occurred on the early Earth, before life began. The process is called photochemistry, and it starts when ultraviolet light from the sun hits methane molecules in the upper atmosphere. The energy breaks the methane apart, releasing hydrogen and leaving carbon atoms free to combine with nitrogen and other elements. This creates molecules like ethane, propane, acetylene, hydrogen cyanide, and many others. These molecules condense into aerosols, tiny particles that drift down through the atmosphere, creating the haze we see. Some of these particles reach the surface, where they accumulate as the dark, sand-like material that covers much of Titan. Scientists are fascinated by Titan because it may show us what Earth was like billions of years ago, before oxygen filled the atmosphere and life transformed the planet. Titan's atmosphere is similar to what Earth's atmosphere might have been like in its early days, rich in nitrogen and methane, full of organic chemistry. By studying Titan, we can learn about the processes that may have led to the origin of life on Earth. It is a window into the past, a preserved snapshot of a world that resembles a younger, colder version of our own planet. The Cassini mission spent 13 years studying Titan, flying by the moon over 100 times and mapping its surface with radar. These observations revealed a world of incredible diversity. There are mountains and valleys, rivers and lakes, plains and dunes. There are even features that look like volcanoes, though they erupt not molten rock, but liquid water and ammonia, a process called cryovolcanism. These cryovolcanoes may bring material from the subsurface ocean up to the surface, depositing it in frozen flows that resemble lava flows on Earth. One of the most intriguing discoveries on Titan is the presence of what appear to be dry lake beds, regions that once held liquid but are now empty. These dry lakes are found mostly in the southern hemisphere, and they suggest that the distribution of liquid on Titan changes over time. During Titan's long seasons, which last about 7 Earth years each, the lakes and seas may shift between hemispheres, evaporating in one region and condensing in another. This seasonal cycle is similar to Earth's water cycle, but it operates on a much longer time scale and with completely different chemistry. If a future mission could land on Titan and explore its surface, it would find a world unlike any other. The sky would be a perpetual twilight, the sun a dim glow behind thick clouds. The air would be cold and heavy, and the ground would be dark, covered in organic sands. In the distance, there might be a lake, its surface smooth and reflective, filled with liquid methane. The landscape would be shaped by erosion, with channels carved by rivers of methane and valleys worn by wind and rain. It would be alien, but also strangely familiar, a place where the processes we know from Earth operate with different materials and different conditions. Callisto is the most heavily cratered moon in the solar system. Orbiting Jupiter beyond Ganymede, Callisto is a world that has barely changed since the solar system formed. Its surface is ancient, covered in impact craters that record billions of years of collisions. Unlike Ganymede, which has regions of young, tectonically active terrain, Callisto shows no signs of geological activity. There are no grooves, no ridges, no evidence of internal heat reshaping the surface. It is a frozen relic, a time capsule from the early days of the solar system. The craters on Callisto are everywhere. They overlap and pile on top of each other, creating a landscape that is rough and chaotic. Some craters are small, just a few kilometers across. Others are enormous, hundreds of kilometers wide, surrounded by concentric rings that spread out across the surface. The largest of these is Valhalla, a multi-ring impact basin over 3,000 kilometers across. Valhalla is so large that it dominates one entire hemisphere of Callisto, a scar from an ancient, catastrophic impact that nearly shattered the moon. Despite being heavily cratered, Callisto is not entirely dead. Beneath its icy crust, there may be a subsurface ocean, similar to Europa's. The evidence is indirect, based on the way Callisto's magnetic field behaves and the composition of its surface. If an ocean exists, it would be deep, buried beneath hundreds of kilometers of ice and rock. It would be cold and dark, isolated from the surface, and unlikely to support life. But the presence of an ocean would mean that Callisto, like so many of Jupiter's moons, is not just a frozen rock, but a complex world with a hidden interior. Callisto is the least affected by Jupiter's radiation of all the Galilean moons. It orbits far enough from the planet that the radiation belts are weaker, making it a relatively safe place by comparison. This has led scientists to suggest that Callisto could be a good base for future missions to the Jupiter system. A spacecraft or habitat on Callisto would be shielded from the worst of Jupiter's radiation, while still being close enough to study the other moons and the planet itself. It is a dark, cratered world, but it may be one of the safest places in the outer solar system for humans to visit. If a person could stand on Callisto, the scene would be one of stark, ancient beauty. The surface would be rough and uneven, covered in craters of all sizes. The ice would be dark and dirty, contaminated by dust and radiation damage. Jupiter would be visible in the sky, smaller than from Io or Europa, but still impressive, a large, banded sphere with swirling storms. The sun would be distant and dim, and the sky would be black, filled with stars. It would be a quiet, lonely place, a moon that has watched the solar system age, unchanged and unchanging, a monument to the passage of time. Rhea is Saturn's second largest moon. After Titan, Rhea is the largest of Saturn's moons, and it is a world of ice and rock, heavily cratered and ancient. Its surface is similar to Callisto's, covered in impact scars from billions of years of bombardment. But unlike Callisto, Rhea shows signs of past geological activity. There are bright rays radiating from some of the younger craters, created by fresh ice excavated from beneath the surface. There are also wispy streaks, long, bright lines that run across the surface, possibly caused by tectonic fractures or ice deposits. Rhea is thought to be differentiated, with a rocky core surrounded by a thick mantle of ice. This structure is similar to many of Saturn's larger moons, and it suggests that Rhea formed from the slow accretion of ice and rock in orbit around Saturn. The surface is ancient, and there are no signs of ongoing geological activity. Rhea is a cold, dead world, frozen in time, its surface a record of the impacts and processes that shaped the Saturn system billions of years ago. One of the mysteries of Rhea is the presence of a possible ring system. Observations from the Cassini spacecraft detected a faint debris disk around Rhea, suggesting that the Moon might have its own rings. If confirmed, Rhea would be the only moon in the solar system with rings, a unique and strange feature. However, later observations did not detect the rings, and their existence remains uncertain. If they do exist, they are very faint and tenuous, made of small particles of dust and ice orbiting the Moon. Rhea's surface is divided into two main types of terrain: heavily cratered regions and lightly cratered regions. The heavily cratered regions are ancient, dating back to the early solar system when impacts were common. The lightly cratered regions are younger, though still billions of years old, and they show signs of past resurfacing events. These events may have been caused by cryovolcanism, where liquid water or slushy ice erupted onto the surface, covering older craters and creating fresh terrain. Today, Rhea is inactive, but its surface tells the story of a more dynamic past. If a visitor could explore Rhea, they would find a world of ice and craters, bright plains and dark valleys. The surface would be rough and ancient, marked by the scars of countless impacts. Saturn would dominate the sky, a massive presence with its rings stretching across the heavens. The sun would be a distant point of light, and the sky would be black and filled with stars. It would be a cold, silent place, a moon that has seen the history of the solar system unfold, a witness to the ages. Dione is another icy moon of Saturn. Slightly smaller than Rhea, Dione is a world of contrasts, with bright, heavily cratered regions and darker, smoother plains. The surface is crisscrossed by bright, wispy streaks, which were a mystery until the Cassini spacecraft revealed their true nature. These streaks are not deposits on the surface, but ice cliffs, bright escarpments where fresh ice has been exposed. The cliffs are the result of tectonic activity, fractures in the ice that have created towering walls hundreds of meters high. Dione is thought to be geologically active, or at least it was in the recent past. The presence of the cliffs suggests that the Moon has been reshaped by internal forces, possibly driven by tidal heating. The smooth plains may have been created by cryovolcanism, where liquid water or ice welled up from below and flowed across the surface, covering older craters. Today, Dione appears quiet, but the evidence suggests that it was once a much more dynamic world. One of the intriguing features of Dione is the presence of a possible subsurface ocean. Like Europa and Enceladus, Dione may hide a layer of liquid water beneath its icy shell. The evidence is not as strong as for other moons, but the possibility is there. If an ocean exists, it would be deep and cold, unlikely to be as active as Europa's ocean, but still a potential habitat for life. The presence of an ocean would also explain the tectonic activity and the cliffs on the surface, signs that the interior is not entirely frozen. Dione orbits Saturn in a region of space where it is affected by the planet's powerful magnetic field and radiation belts. The surface is bombarded by energetic particles which darken the ice and create chemical changes. Over time, this radiation has altered the surface, creating regions that are darker and more heavily processed than others. The leading hemisphere, which faces forward as Dione orbits Saturn, is darker than the trailing hemisphere, a result of the constant bombardment by particles from the planet. If a person could stand on Dione, they would see a landscape of ice and cliffs, bright scarps rising against the dark sky. Saturn would fill the heavens, its rings edge-on or wide, depending on the season. The sun would be a pale disk, and the light would be dim. The surface would be rough and cratered, with smooth plains stretching between the impact scars. It would be a place of ancient beauty, a moon shaped by impacts and tectonics, frozen in time but bearing the marks of its past. Tethys is a world of ice. One of Saturn's mid-sized moons, Tethys is almost entirely composed of water ice, with little to no rock. This makes it one of the least dense moons in the solar system, so light that it would float in water if there were a bathtub large enough to hold it. The surface is bright and heavily cratered, covered in impact scars from billions of years of bombardment. The most prominent feature on Tethys is Odysseus, a massive impact crater nearly 400 kilometers across, almost 1/3 the diameter of the moon itself. Odysseus is a strange crater. Unlike most impact craters, which have deep floors and high rims, Odysseus is shallow and flat. The floor of the crater has rebounded, rising up to almost the level of the surrounding surface. This rebound is a result of the icy composition of Tethys. When the impact occurred, it created a deep depression, but over time, the warm, plastic ice in Tethys's interior flowed, allowing the crater floor to rise. The result is a crater that is more of a shallow bowl than a deep pit, a scar that has been softened by the slow movement of ice. Another prominent feature on Tethys is Ithaca Chasma, a massive canyon that stretches for over 2,000 kilometers across the surface. The canyon is up to 100 kilometers wide and several kilometers deep, a vast scar that cuts through the ice. The origin of Ithaca Chasma is uncertain. One theory is that it formed when Tethys's interior froze and expanded, cracking the surface. Another theory is that it is related to the impact that created Odysseus, the shock waves from the collision fracturing the moon on the opposite side. Either way, Ithaca Chasma is a dramatic feature, a reminder of the forces that have shaped Tethys over its history. Tethys is tidally locked to Saturn, always showing the same face to the planet. The surface is divided into bright, heavily cratered terrain and darker, smoother plains. The plains are thought to be the result of cryovolcanism, where liquid water or slushy ice flowed onto the surface and froze, covering older craters. Today, Tethys is geologically inactive, a cold, frozen world with no signs of internal heat or ongoing processes. It is a relic of the past, a moon that has been shaped by impacts and tectonics, but now rests, unchanging, in orbit around Saturn. If a visitor could explore Tethys, they would find a world of ice and craters, vast canyons and shallow impact basins. The surface would be bright and reflective, shining in the dim light of the distant sun. Saturn would be overhead, massive and beautiful, its rings stretching across the sky. The gravity would be weak, making it easy to move across the surface, but also easy to float away if one were not careful. It would be a quiet, peaceful place, a moon of ice, ancient and serene, orbiting silently through the darkness. Ceres is a dwarf planet, but it orbits the Sun in the asteroid belt, and it is often grouped with asteroids rather than planets. However, recent observations have revealed that Ceres is more complex than a simple asteroid. It is large enough to be round, shaped by its own gravity, and it has features that suggest geological activity. The surface is covered in craters, but there are also bright spots, mysterious regions that reflect more sunlight than the surrounding terrain. These bright spots were a puzzle until the Dawn spacecraft arrived and revealed their true nature: deposits of salt left behind when water ice sublimated from the surface. Ceres may have a subsurface ocean, or at least pockets of liquid water beneath its icy crust. The evidence comes from the bright spots and from the detection of water vapor escaping from the surface. When the Dawn spacecraft arrived, it observed that the bright spots were concentrated in certain craters, particularly in a crater called Okator. The bright material is sodium carbonate, a salt that forms when briny water reaches the surface and evaporates, leaving the salt behind. The presence of this salt suggests that liquid water exists beneath the surface, possibly in isolated pockets or in a global layer. The surface of Ceres is ancient and heavily cratered, but there are also signs of recent activity. Some regions appear smooth, covered in a layer of material that may have been deposited by cryovolcanism. There are also mountains, including one called Ahuna Mons, which rises over 4,000 meters above the surrounding terrain. Ahuna Mons is thought to be a cryovolcano, a mountain formed by the eruption of ice and salt rather than molten rock. If this is true, it would make Ceres one of the few bodies in the asteroid belt with recent geological activity. Ceres is fascinating because it blurs the line between asteroids and icy moons. It is large enough to have a differentiated interior with a rocky core and an icy mantle, similar to many moons of the outer planets. But it orbits the Sun, not a planet, and it formed in the asteroid belt, a region filled with rocky and metallic bodies. Ceres is a hybrid, part asteroid, part icy moon, and it may hold clues to the early solar system when the line between these types of bodies was less clear. If a person could visit Ceres, they would find a world that is neither quite an asteroid nor quite a moon. The surface would be rough and cratered, covered in dark, rocky material mixed with ice. The bright spots would shine like beacons, deposits of salt gleaming in the sunlight. The gravity would be weak, about 3% of Earth's, making movement slow and deliberate. The Sun would be brighter than at Saturn or Jupiter, but still dimmer than on Earth. It would be a lonely place, a dwarf planet orbiting the Sun among the asteroids, a world that has secrets hidden beneath its surface. Nereid is Neptune's strangest moon. While Triton is the largest and most famous of Neptune's moons, Nereid is the most unusual. It has one of the most eccentric orbits of any moon in the solar system, swinging from a close approach of about 1.5 million kilometers to as far out as 9.5 million kilometers. This extreme ellipse suggests that Nereid is a captured object, possibly a Kuiper belt object, or a scattered disk object that was snared by Neptune's gravity. The orbit is so eccentric that Nereid's distance from Neptune changes by a factor of 7 over the course of a single orbit. The surface of Nereid is unknown. The only spacecraft to visit Neptune, Voyager 2, flew by in 1989, but it did not pass close enough to Nereid to capture detailed images. What we know comes from ground-based observations and the distant images from Voyager. Nereid appears to be a small, irregular object, about 340 kilometers across, and its surface is thought to be a mix of rock and ice. The color is grayish, suggesting that the surface has been altered by radiation or by the presence of dark, organic material. Nereid's extreme orbit means that it experiences huge variations in temperature and radiation exposure over the course of its orbit. When it is close to Neptune, it is bathed in the planet's radiation and experiences higher temperatures. When it is far from Neptune, it is cold and isolated, exposed to the solar wind and cosmic rays. This makes Nereid a challenging object to study, and it remains one of the least understood moons in the solar system. If Nereid is a captured object, it raises interesting questions about the history of the Neptune system. How did Neptune capture such a large object into such an eccentric orbit? Was there a collision, or did Neptune's gravity slowly pull Nereid in over millions of years? And what does Nereid's presence tell us about the population of objects in the outer solar system? These are questions that can only be answered with more observations and possibly a dedicated mission to the Neptune system. If a visitor could travel to Nereid, they would find a small, irregular world tumbling through space in a lonely, eccentric orbit. The surface would be rough and cratered, and the gravity would be weak. Neptune would appear in the sky, but its size would vary dramatically depending on Nereid's position in its orbit. At its closest approach, Neptune would fill the sky, a massive blue sphere with storms and clouds. At its farthest, Neptune would be a small, distant disk, barely larger than a bright star. It would be a place of extremes, a moon that experiences the full range of conditions in the outer solar system. Proteus is a large but strangely shaped moon of Neptune. Orbiting closer to Neptune than Triton, Proteus is the second largest moon of Neptune, but it is irregular in shape, lumpy and asymmetrical. Proteus is just at the edge of being large enough to be pulled into a spherical shape by its own gravity, and it sits at the boundary between small, irregular moons and large, round moons. If it were any larger, it would be round. If it were any smaller, it would be even more irregular. It is a moon on the edge, a body that almost made it to spherical, but not quite. The surface of Proteus is dark and heavily cratered. The largest crater is Pharos, over 200 kilometers across, almost half the diameter of the moon. The impact that created Pharos must have come close to shattering Proteus entirely, and it is remarkable that the moon survived. The surface is covered in smaller craters as well, evidence of billions of years of bombardment. There are also ridges and valleys, signs that the surface has been fractured and reshaped by tectonic forces or by the rebound from large impacts. Proteus orbits Neptune inside the orbit of Triton, and it is affected by the gravitational influence of both Neptune and Triton. This makes its orbit slightly unstable over long timescales, and eventually, Proteus may either collide with another moon or be ejected from the Neptune system. For now, though, it remains in place, a dark, cratered moon orbiting in the shadow of Triton, often overlooked but no less interesting for it. If a person could visit Proteus, they would find a world that is rough and irregular, a moon that feels more like a large asteroid than a traditional moon. The surface would be dark and dusty, and the gravity would be weak. Neptune would dominate the sky, a massive blue sphere, close and imposing. The sun would be a distant, cold point of light, barely warming the surface. It would be a quiet, lonely place, a moon that orbits in the shadow of Triton, forgotten by most but holding its own secrets. Phoebe is a retrograde moon of Saturn, orbiting far from Saturn, in the opposite direction to most of the planet's moons. Phoebe is thought to be a captured object from the Kuiper belt. Its orbit is tilted and retrograde, and its composition is different from Saturn's inner moons. Instead of being mostly ice, Phoebe is rich in rock and carbon, making it darker and denser. It is a remnant from the outer solar system, a visitor that wandered too close to Saturn and was captured billions of years ago. The surface of Phoebe is dark and heavily cratered, covered in a layer of dark material that absorbs most of the sunlight. The Cassini spacecraft flew by Phoebe in 2004 and captured detailed images of the surface. The images showed a world covered in craters, ridges, and valleys, with bright ice exposed in the walls of some craters. This suggests that beneath the dark exterior, Phoebe has a layer of ice hidden below the dusty surface. The dark material is thought to be organic compounds, the same kind of material that coats many objects in the Kuiper belt. Phoebe is the source of Saturn's outermost ring, the Phoebe ring. This ring is enormous, extending millions of kilometers from Saturn, but it is so faint that it was only discovered in 2009 using infrared observations. The ring is made of dust particles knocked off Phoebe by micrometeorite impacts. These particles drift inward toward Saturn, and some of them eventually collide with other moons, coating their surfaces. Iapetus, in particular, is thought to have its dark hemisphere coated by material from the Phoebe ring. If a visitor could stand on Phoebe, they would find a dark, ancient world, a piece of the Kuiper belt transported to the Saturn system. The surface would be rough and cratered, covered in dark dust. Saturn would be visible in the sky, but small and distant, a pale yellow disk with faint rings. The sun would be dim, and the sky would be black and filled with stars. It would be a lonely place, a moon far from Saturn, orbiting in the opposite direction, a wanderer that found a temporary home. Amalthea is a small red moon of Jupiter, orbiting inside the orbit of Io. Amalthea is one of Jupiter's inner moons, and it is a strange, irregular object. It is reddish in color, the result of sulfur from Io's volcanoes coating its surface. Amalthea is shaped like a potato, elongated and lumpy, and it is heavily cratered. The largest crater, Pan, is over 90 kilometers across, nearly as wide as the moon itself. Despite its small size, Amalthea plays a role in Jupiter's ring system, contributing dust particles that feed the faint rings. The surface of Amalthea is rough and ancient, covered in impact scars and coated in sulfur. The red color makes it stand out among Jupiter's other moons, most of which are gray or white. The sulfur comes from Io, carried through space by Jupiter's magnetic field and deposited onto Amalthea's surface. Over millions of years, this sulfur has built up, giving the moon its distinctive color. Amalthea is one of the few moons discovered from Earth before the era of spacecraft. It was discovered in 1892 by the astronomer Edward Emerson Barnard, the last moon to be discovered visually through a telescope before photography and spacecraft took over. Today, Amalthea is one of many small moons orbiting Jupiter, often overlooked in favor of the larger Galilean moons, but it remains an interesting object, a small, red world in the shadow of Jupiter. If a person could visit Amalthea, they would find a small, irregular world covered in red dust and craters. Jupiter would fill the sky, a massive, swirling presence, close and overwhelming. The radiation would be intense, and any visit would need to be brief. The surface would be rough and uneven, and the gravity would be weak. It would be a harsh, inhospitable place, but the view of Jupiter would be unforgettable. The moons of Uranus are named after characters from Shakespeare and Alexander Pope. Unlike most moons in the solar system, which are named after figures from Greek and Roman mythology, the moons of Uranus take their names from literature. The 5 largest moons, Miranda, Ariel, Umbriel, Titania, and Oberon, are named after characters from Shakespeare's plays. The smaller moons are named after characters from the works of Alexander Pope. This literary tradition gives the Uranus system a unique character, a reminder that the solar system is not just a collection of rocks and ice, but also a canvas for human imagination. The largest of Uranus's moons, Titania, is a heavily cratered world with signs of past geological activity. Its surface is a mix of old, cratered terrain and younger, smoother regions, suggesting that the moon was once reshaped by internal forces. There are also valleys and canyons, evidence of tectonic activity. Oberon, the second largest moon, is similar, with a heavily cratered surface and signs of past volcanism. Both moons are thought to be differentiated, with rocky cores surrounded by icy mantles. Ariel and Umbriel are smaller than Titania and Oberon, but they are also interesting. Ariel has a young surface, with fewer craters and many valleys and ridges, signs that it was geologically active in the past. Umbriel, by contrast, is dark and heavily cratered, one of the darkest objects in the solar system. Its surface is ancient and unchanged, a record of the early solar system. The contrast between Ariel and Umbriel is striking, 2 moons of similar size but completely different histories. If a visitor could tour the moons of Uranus, they would find a diverse collection of worlds, each with its own character. From Miranda's chaotic patchwork surface to Titania's ancient craters, from Ariel's young valleys to Umbriel's dark plains, the moons of Uranus offer a glimpse into the variety and complexity of the outer solar system. Uranus itself would be a constant presence in the sky, a pale blue-green sphere tilted on its side, slowly rotating through the seasons. The Trojans of larger moons create their own miniature systems. Some of the larger moons have their own gravitational influence zones, where smaller objects can orbit in stable positions. These are called Trojan points, and they exist 60 degrees ahead of and behind a moon in its orbit around the planet. At these points, the gravitational forces of the planet and the moon balance out, creating pockets of stability where small objects can gather. Saturn's moon Tethys has two Trojans, Telesto and Calypso, small moons that share its orbit. Dione also has two Trojans, Helene and Polydeuces. These Trojan moons are tiny, irregular objects, just a few kilometers across, but they occupy stable positions that have likely existed for billions of years. The Trojan moons are fascinating because they show how gravity can create order even in the chaos of space. The positions they occupy are mathematically predictable, and they demonstrate the elegant balance of forces that governs the motion of objects in orbit. These tiny moons are not just random debris. They are held in place by the same gravitational dynamics that shape the entire solar system, from the smallest particle to the largest planet. They are part of a cosmic dance, moving in harmony with their larger companions, held in place by invisible forces that have existed since the solar system formed. If a spacecraft could visit one of these Trojan moons, it would find a small, irregular world, slowly tumbling through space. The larger moon, Tethys or Dione, would be visible in the distance, a large, bright sphere against the darkness. The Trojan moon would be rough and cratered, covered in dust and ice, and its gravity would be almost non-existent. Saturn would be nearby, massive and beautiful, its rings stretching across the sky. It would be a peaceful place, a tiny moon in a stable orbit, held in place by the balance of forces, a small piece of the larger puzzle of the Saturn system. Some moons have been torn apart by tidal forces. The solar system is not a static place. Over billions of years, moons have been destroyed, shattered, and reformed. One of the ways this happens is through tidal forces. When a moon orbits too close to its planet, the gravitational pull on the near side of the moon is stronger than on the far side. This difference creates stress, stretching, and pulling the moon. If the moon crosses the Roche limit, the point at which these tidal forces become stronger than the moon's own gravity, the moon is torn apart. The result is a ring of debris, pieces of the former moon orbiting the planet in a flat disk. This is likely what created the rings of Saturn, Jupiter, Uranus, and Neptune. These rings are not permanent features. They are the remnants of moons that wandered too close or were shattered by impacts. Over time, the particles in the rings collide and grind down into smaller and smaller pieces. Some particles spiral inward and fall into the planet. Others are pushed outward by the gravity of shepherd moons. The rings are constantly changing, evolving, and eventually they will fade. The moons that created them will be forgotten. Their only legacy, the beautiful rings that encircle their planets. The process of tidal disruption is slow but inevitable. Phobos, Mars's largest moon, is slowly spiraling toward the planet, and in 50 million years, it will cross the Roche limit and be torn apart. When that happens, Mars will gain a ring system, a band of debris encircling the planet. This ring will be temporary, lasting perhaps a few 100 million years before the particles spiral down into Mars's atmosphere or are ejected by gravitational interactions. The same fate awaits Triton, Neptune's largest moon, which is also spiraling inward. In a few billion years, Triton will be shredded, and Neptune will gain a new ring system. The solar system is a place of constant change, where moons are born, live, and die, their remnants scattered through space. If a person could witness the destruction of a moon, it would be a sight both terrible and beautiful. The moon would approach the planet, slowly at first, then faster as it neared the Roche limit. As it crossed the limit, cracks would appear on the surface, widening and deepening as the tidal forces pulled the moon apart. Pieces would break away, tumbling into orbit, colliding with each other, shattering into smaller fragments. Over time, these fragments would spread out, forming a ring around the planet, a glowing band of ice and rock. It would be a process of destruction and creation, the end of one moon and the beginning of a ring system, a reminder that nothing in the universe is permanent. The small moons of the outer solar system are often captured objects. Many of the small, irregular moons orbiting the giant planets are not original members of those systems. Instead, they are captured objects, asteroids or Kuiper belt objects that wandered too close and were snared by the planet's gravity. These captured moons often have eccentric, tilted orbits, and they may orbit in the opposite direction to the planet's rotation. Their surfaces are dark and rocky, different from the icy moons that formed in place around the planets. Jupiter has dozens of these small, irregular moons, many of them grouped into families based on their orbits. These families are thought to be the fragments of larger objects that were captured and then shattered by collisions. Saturn, Uranus, and Neptune also have irregular moons, each one a visitor from the outer solar system pulled into orbit and held there by gravity. These moons are time capsules, preserving the composition and structure of objects from the early solar system, before the planets fully formed and the solar system settled into its current configuration. Studying these captured moons gives scientists clues about the population of objects in the outer solar system. How many asteroids and Kuiper belt objects are there? What are they made of? How did they form? These questions can be answered, in part, by studying the captured moons, which are samples of the material that filled the early solar system. Each captured moon is a piece of the puzzle, a fragment of a larger story about how the planets and moons came to be. If a visitor could explore one of these captured moons, they would find a small, dark world, tumbling through space in an eccentric orbit. The surface would be rough and rocky, covered in dust and craters. The planet would be visible in the distance, a large, bright sphere, sometimes close, sometimes far, depending on the moon's position in its orbit. The sun would be a tiny point of light, and the sky would be black and filled with stars. It would be a lonely place, a moon far from home, orbiting a planet that is not its own, a wanderer held by gravity in a place it never chose. The surfaces of icy moons are constantly being resurfaced by space weathering. Even though many moons appear ancient and unchanging, their surfaces are constantly being altered by processes that happen slowly over millions of years. Space weathering includes impacts from micrometeoroids, bombardment by high-energy particles from the Sun and from the planet's magnetosphere, and the sublimation of ice in the vacuum of space. These processes darken the surface, create a layer of dust called regolith, and alter the chemistry of the ice. On Europa, for example, the surface is constantly being bombarded by particles from Jupiter's magnetosphere. These particles break apart water molecules, creating oxygen and hydrogen. Some of this oxygen escapes into space, but some remains on the surface, bound in compounds like hydrogen peroxide. The surface is also darkened by radiation damage, which creates complex organic molecules from the simple compounds on the surface. Over time, these processes change the appearance and composition of the surface, making it darker and more chemically complex. On Enceladus, the surface is constantly being renewed by fresh ice from the geysers at the South Pole. This ice falls back onto the surface, covering older terrain and creating a bright, fresh coating. This process makes Enceladus one of the brightest objects in the solar system, because the surface is always being resurfaced with pristine ice. Without this resurfacing, Enceladus would gradually darken over time, just like other icy moons. The process of space weathering is slow, but it is relentless. Every icy moon in the solar system is being gradually altered by the environment it orbits in. The surfaces we see today are not the same as they were a billion years ago, and they will not be the same a billion years from now. The moons are constantly changing, evolving, shaped by the forces of space, by radiation and impacts and sublimation. They are not static, but dynamic, living records of the processes that shape worlds. If a person could watch an icy moon over millions of years, they would see the surface change. Bright regions would darken, craters would fill with dust, fresh ice would cover old terrain. Geysers would erupt and deposit material on the surface. Impacts would create new craters, and old craters would be erased by erosion or covered by flows. The moon would be in constant motion, its surface a palimpsest, a text that is constantly being written over, erased and rewritten. It would be a reminder that nothing in the universe is permanent, that even the seemingly eternal moons are constantly changing, shaped by time and the forces of nature. The mysteries of the moons will take many more missions to solve. Despite decades of exploration, there is still so much we do not know about the moons of the solar system. We have visited some of them with spacecraft, capturing images and taking measurements, but many remain unexplored. The surfaces of most of the small, irregular moons have never been seen up close. The subsurface oceans of Europa, Enceladus, and other moons have never been sampled. The chemistry of Titan's lakes has never been analyzed directly. There are countless mysteries waiting to be solved, questions that can only be answered with more missions, more observations, more exploration. Future missions are planned to explore these moons. NASA is developing the Europa Clipper mission, which will orbit Jupiter and make dozens of close flybys of Europa, studying its ice shell and searching for signs of the ocean below. The European Space Agency is developing the JUICE mission, which will study Jupiter's icy moons, including Ganymede, Callisto, and Europa. NASA is also considering a mission to Enceladus, which would fly through the geysers and sample the water from the subsurface ocean. These missions will answer some of the questions we have about these moons, but they will also raise new questions, revealing new mysteries that we cannot yet imagine. One of the most exciting possibilities is the search for life. If life exists on any of these moons, it would be one of the most important discoveries in human history. It would mean that life is not unique to Earth, that it can arise in other environments, in other conditions. It would change our understanding of biology, of chemistry, of the universe itself. The search for life on the moons of the outer solar system is one of the driving forces behind the missions being planned. Scientists are looking for biosignatures, signs of life, in the water from Enceladus's geysers, in the ice on Europa's surface, in the chemistry of Titan's atmosphere. These searches are difficult, and success is not guaranteed, but the potential rewards are enormous. If a future mission were to discover life on one of these moons, it would be a moment that would resonate across history. Imagine the announcement, the images, the data showing undeniable evidence of living organisms in the ocean of Europa or the plumes of Enceladus. It would be a moment of unity, a reminder that we are not alone, that the universe is full of possibilities. It would inspire a new generation of explorers, scientists, and dreamers, people who would dedicate their lives to understanding and exploring these distant worlds. The moons are waiting, and with them, the answers to some of the deepest questions we can ask. As we come to the end of our journey, let us return to the quiet of the present moment. We have traveled far tonight, to moons of fire and ice, to worlds with hidden oceans and towering cliffs, to tiny fragments of rock and massive bodies larger than planets. We have explored the strange and the beautiful, the violent and the serene. Each moon we visited is a world unto itself, with its own history, its own character, its own story. They are not just cold rocks orbiting distant planets. They are places, real places, waiting to be explored, waiting to reveal their secrets. These moons are part of the same solar system we live in, part of the same cosmic neighbourhood. They formed from the same cloud of gas and dust that gave birth to the sun and the planets. They have been shaped by the same forces that shaped Earth, gravity, heat, time, impact, erosion. They are our neighbours, our companions in the journey through space. And they remind us that the universe is vast, filled with wonders, filled with mysteries, filled with places we have yet to discover and understand. As you lie here now, feeling the weight of sleep beginning to settle over you, let these images linger in your mind. Picture the smooth, cracked ice of Europa, hiding an ocean beneath. See the fiery volcanoes of Io erupting in silence. Imagine the methane lakes of Titan reflecting the orange haze. Watch the geysers of Enceladus spraying water into space. These are real places, and they exist right now, even as you drift towards sleep. They are out there, orbiting their planets, spinning through the darkness, unchanged by whether we see them or think about them. They simply are. The universe does not wait for us, but it also does not rush. It moves at its own pace, slow and steady, indifferent to our hurry and our impatience. The moons orbit their planets, day after day, year after year, millennium after millennium. The volcanoes erupt, the geysers spray, the ice cracks and refreezes, all in their own time. There is no urgency, no deadline, no pressure, just the slow, eternal motion of celestial bodies, held in place by gravity, shaped by time, existing in the vast silence of space. And you, too, can move at that pace. There is no need to hold on to these thoughts, no need to remember every detail, no need to understand everything right now. Just let the images flow through your mind, gentle and soft, like a river carrying leaves. Let them drift past, and let yourself drift with them. Let the moons carry you into sleep, into dreams, into the quiet darkness where thoughts dissolve and consciousness fades. There is nothing you need to do, nowhere you need to be. Just rest, just breathe, just let go. The moons are still out there, and they will be there tomorrow, and the next day, and for billions of years to come. They are patient, and so can you be. There is no need to rush, no need to worry, no need to think about anything at all. Just close your eyes, if they are not already closed. Let your body sink deeper into the bed, into the pillow, into the comfort that surrounds you. Feel the weight of your limbs, heavy and relaxed. Feel the rhythm of your breathing, slow and steady. Feel the quiet of the night, the stillness, the peace. Imagine yourself floating through space, drifting past these strange moons, seeing them with your own eyes. You move slowly, effortlessly, carried by some invisible current. There is no sound, no wind, no gravity pulling you down, just the vast silence of space and the beauty of these distant worlds. You pass Europa, its ice gleaming in the dim sunlight. You pass Io, its volcanoes glowing red against the darkness. You pass Titan, shrouded in orange haze. You pass Enceladus, its geysers shimmering like diamonds. Each moon is a moment, a brief encounter, and then you move on, carried by the current, deeper into sleep. The stars are around you, thousands of them, millions of them, points of light stretching into infinity. The planets are distant spheres, glowing softly, their moons orbiting in silent procession. The universe is vast and full, and you are a part of it, a small but essential part. You are made of the same material as the stars, the same atoms that formed in the heart of ancient supernovae. You are stardust, cosmic dust, part of the great cycle of creation and destruction that has been going on since the beginning of time. And now, as you drift deeper into sleep, as the images fade and the thoughts dissolve, let yourself become part of that cycle. Let yourself become part of the universe, part of the silence, part of the darkness. There is no separation, no boundary, no edge. Just the infinite expanse, and you, floating through it, free and weightless. There is nothing to hold on to, nothing to resist. Just let go, just surrender, just sleep. The moons are watching over you, silent guardians in the night. They have been there for billions of years, and they will be there long after you wake. They are patient, timeless, eternal, and they remind you that you, too, are part of something larger, something that stretches beyond your individual life, beyond this moment, beyond this night. You are part of the cosmos, part of the great story of the universe, and that story is still being written, still unfolding, still revealing itself in ways we cannot yet imagine. So rest now. Let the moons carry you into dreams. Let the stars watch over you. Let the universe hold you in its vast, gentle embrace. There is nothing you need to do, nothing you need to think about. Just breathe, just drift, just sleep. And when you wake, the moons will still be there, orbiting their planets, spinning through the darkness, waiting for the day when we will visit them, explore them, understand them. But for now, they are content to wait, and so can you be content to rest. Good night.